Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you how you should answer questions from test 2. Altogether, we have 6 different questions and let's start with the first one. Question number 1. In an aqueous solution with a concentration of 0.2 molar, ammonia undergoes hydrolysis to produce ammonium ion and hydroxide ion with a Kc value of 1.8 times 10 to the power of negative 3. Determine the pH of ammonia aqueous solution at equilibrium. The first step in answering this question is that we need to write the balance equation for the reaction. So we have ammonia in aqueous solution. Because it is in aqueous solution, we need to add water. Hence, it will dissociate to become ammonium and also hydroxide ion. Alright, moving on to the second step is we want to make the ice diagram. So ICE. So initially, the concentration is 0.2. So in ice diagram, we do not have to look upon your water. And at the beginning, there's nothing formed as the product. So in the change, so here is negative x, positive x and positive x. Therefore, at equilibrium is going to be just a summation of the initial and also the change. Alright, so given in the question is that the value of Kc is 1.8 times 10 to the power of negative 3. So what we can do is that we can write your Kc is equivalent to whatever in the product, which is NH4 and the concentration of OH minus divided by the concentration of NH3, right? Whereby the value of Kc here is the value given in the question, which is 1.8 times 10 to the power of negative 3. So we are going to use this one, which is x squared divided by 0.2 minus x. Alright, so since we already know what is the Kc, so in here what we are going to do is we are going to use the approximation method, whereby we are going to remove this x. Therefore, you will get 1.8 times 10 to the power of negative 3 is actually equivalent to x squared divided by 0.2. So what we are going to do is we bring this up here. So you will get, therefore from here we will get x squared is equivalent to 0.2 times 1.8 times 10 to the power of negative 3. So your x is the square root of this value, which is 3.6 times 10 to the power of negative 4. Therefore, you will get your x equivalent to 1.8974 times 10 to the power of negative 2. Alright, so since when we calculate the value of x, we are using the approximation method, so we need to test whether this value of x is valid or not. So what we are going to do is we are going to do the test. So your test is equivalent to the value of x divided by the initial concentration. So initial concentration is 0.2 times 100%. So 1.8974 times 10 to the power of negative 2 divided by 0.2 times 100. So apparently we will get 9.4870%. So this one is more than 5%. So this doesn't approve. So what we are going to do is that we are going to substitute this value here into the value of x that we omitted just now in the approximation method. Alright, so what we are going to do is we are going to substitute this x with the value of x that we have calculated just now. So we will get x squared divided by 0.2 minus 1.8974 times 10 to the power of negative 2, right? So from here you will get your x squared should be equivalent to 3.2585 times 10 to the power of negative 4. So your x is the square root of this value. So you should get x is equivalent to 1.8051 times 10 to the power of negative 2. Right, so you were asked to determine the pH of ammonia aqueous solution at equilibrium. So in order for you to calculate the pH, so the first thing that you need to look at is the concentration of OH minus. So apparently the concentration of OH minus is equivalent to the value of X. So we can now calculate the POH. POH is equivalent to negative log OH minus. So we're just going to plug in the value of X that we get, 1.8051 times 10 to the power of negative 2. Therefore, you will get your POH is equivalent to 1.7435, right? But in the question, you were asked to find what is pH. So pH plus POH is equivalent to 14. So your pH is equivalent to 14 minus your POH, equivalent to 14 minus 1.7435. Therefore, you will get your pH is equivalent to 12.2565. So this is the final answer for the first question. Alright, so let's move on to question number 2. Approximate the ionic strength of solution resulting from the accurate dissolution of 0.0746 gram of KCl in 200 centimeter cube of distilled water upon homogenized mixing with 0.008 molar of AlCl3. Right, for this question, you were given the mass for KCl and the volume of water that you're using. So the first thing that you need to do is you need to find what is the number of mole. Right, so the number of mole for KCl is equivalent to the mass over RMM. So the mass is given to you in the question, 0.0746, and the RMM for KCl is going to be 39.0983 plus 35.453. Therefore, you will get the number of mole for KCl is equivalent to 1.0006 times 10 to the power of negative 3. Right. So the next step is you want to find the molarity. So molarity is equivalent to mole over liter. So you need to convert 200 centimeter cube into liter beforehand, and the number of mole that we are going to use is this value here that we have already calculated. And now we are going to use the value of the number of mole, and I have already converted from centimeter cube to liter. So you will get your molarity is equivalent to 5.0033 times 10 to the power of negative 3. So this is the molarity for the KCl. So now only we can calculate what is the ionic strength for the mixture of these solutions. So from the calculation just now, we know that the molarity of KCl is 0.005 molar. Therefore, from this KCl, you have K plus and Cl minus. So another one that we have from the question is 0.008 molar of aluminum chloride. Therefore, you will get Al3 positive and also Cl minus. But here in this question, we have 3 over here. Therefore, we have 3Cl minus. Okay, another thing that you need to bear in mind is that even though we have Cl on both sides, but the concentration are not the same, so we cannot calculate it together. So we are going to calculate the ionic strength individually. So the ionic strength, the formula that you can use is equivalent to half the summation of your concentration and also your ionic strength times to the power of 2, right? So we are going to do it one by one. I'm going to start with the KCl. So it's going to be 0.005, and then K is positive 1 to the power of 2. Right, so we are going to add another 0.005, and now is for the chlorine, negative 1 to the power of 2. So this one should be plus. So plus for the other side, which is 0.008 times positive 3 to the power of 2 plus 0.008 times negative 1 to the power of 2, but here we have 3, so at the beginning here you should have 3 times 0.008, then only you times negative 1 to the power of 2, right? So from here you just have to press your calculator. You should get 9.6 times 10 to the power of negative 2 plus 1.0007 times 10 to the power of negative 2. Therefore, you will get your ionic strength is equivalent to 5.3004 times 10 to the power of negative 2. So this is the final answer for the second question. Moving on to question number 3. Calculate the duration in hours for 1.72 times 10 to the power of 2 grams of chromium to be deposited onto a thin steel of an antique car bumper during chrome plating process, given that the bumper is dipped into an acidic Cr2O7 solution and served as the cathode in an electrolytic cell with a current of 21.4 amperes. Right, so given to you in this question, it was dipped inside the acidic solution of Cr2O7 with the ionic form of 2 minus. So now what we are going to do is we need to know what is the oxidation number for your chromium. So I'm just going to write again Cr2O7 2 minus. Therefore, we know that we want to calculate the Cr, which is 2x, because we have 2 around here. And then we need to plus the oxygen. So oxygen is a constant value. So because we have 7 oxygen around here, so 7 times oxygen should always be negative 2. Should be equivalent to the value of the ion, so it's equivalent to negative 2. So what we can do now, we are going to copy again. So 2x plus negative 14 is equivalent to negative 2. So your 2x is equivalent to negative 2 plus 14. So your x is equivalent to 12 divided by 2, which is equivalent to 6. So the oxidation number for your chromium is actually equivalent to 6. Alright, so in this question you were given the mass of chromium as well. Since we are given the mass, so what we can calculate is the number of mole. So the number of mole for chromium is equivalent to the mass over RMM. So apparently the mass is already in grams, so I'm just going to copy from the question. 1.72 times 10 to the power of 2 divided by the relative molar mass for chromium, which is 51.996. Hence, you will get the number of mole for chromium is equivalent to 3.3079 mole. Okay, now from both calculation that we have calculated just now, what we can do is that we know that the chromium, the oxidation number is positive 6. So we can write Cr positive 6 or 6 positive. Therefore, it needed like 6 electron. Then only it can turn into chromium, right? So in other words, we can say that 6 Faraday, which is totally dependent on the number of electron here, should produce 1 mole of chromium, right? So now, because we only have this much mole of chromium, right? So we are going to calculate how many Faraday is available. So 1 mole, 6 Faraday. So we have this much mole, 3.3079 mole. So it's going to be 6 times 3.3079. Hence, you will get 19.8474 Faraday. So now what we are going to do is to convert this Faraday into Coulomb. So 1 Faraday is equivalent to 96,500 Coulomb. So from the calculation just now, we have 19.8474. Hence, it's going to be 96,500 times 19.8474. Therefore, you will get 1915274.10 Coulomb. Right. So from here, then only we can use this value to calculate Q equivalent to IT. So the current is given to you is the ampere, and Q is this value here. So you will get how many hours they take to electroplate this car bumper. Right, so Q equivalent to IT. So the Q that we have calculated just now is equivalent to 1915274.10 Coulomb, equivalent to the current 21.4 ampere, and then you want to find the time. So the time is equivalent to 1915274.10 divided by 21.4. So your time, you will get equivalent to 89498.7897. Alright, so remember the time here that you have calculated now is in second, but in the question you were asked to convert it to hours. So remember that 1 hour is equivalent to 3600 seconds. So we are going to convert again to hours. So it means that this value we need to divide with 3600. Therefore, you will get equivalent to 24.8607 hours. So this is the final answer for the third question. Let's move on to question number 4. The reaction between vanadium and lead proceed as below. Distinguish if this reaction is spontaneous or non-spontaneous, given that the standard reduction potential are as follows. In this question, you were given the equation. Therefore, we need to use the equation to identify which element shall be the anode and which shall be the cathode in accordance to whether they undergoes oxidation or reduction process. Alright, in this case, vanadium goes from positive 2 into 0, so definitely this is reduction process, and lead goes from 0 to positive 2, which is oxidation process. And you need to remember the formula red cat. So reduction occurs at cathode, whereby this one, the vanadium, is undergoing the reduction. Okay, since we were given the reduction potential, so we are going to choose the one that is undergoing the reduction first, which is the vanadium. So for vanadium reduction at cathode, we are just going to copy whatever they have given us in the equation from the question. Therefore, it is equivalent to 1.180 volt. Alright, for anode, instead of undergoing the reduction process, it undergoes oxidation process. So you need to twist a bit on the equation. So we will start with lead. So lead, you will donate electrons. So you will get lead 2 positive. So remember here, because it's negative, so you're going to turn it into positive, 0.126 volt. So from here, you can write the overall reaction. So lead plus vanadium 2 positive will produce lead 2 positive plus vanadium. And you just have to do the summation of this, should be equivalent to negative 1.054 volt. Okay, so in this question, you were asked to distinguish if this reaction is spontaneous or non-spontaneous. So what we are going to do is we're going to look at the anode cell values. So apparently the value here is negative. Therefore, when it's negative, it is a non-spontaneous process. So this is the final answer for the fourth question. Question number 5. Approximate the rate at which nitrogen dioxide is produced during the decomposition of N2O5 to nitrogen dioxide and oxygen gas if the rate of N2O5 decomposition in a reaction vessel at a specific moment is 4.2 times 10 to the power of negative 7 molar per second. Alright, so in this question, you were given a clue whereby the decomposition of N2O5, it will become nitrogen dioxide and also oxygen gas. So this will help you to write the balance equation. So it states here that N2O5 will decompose into NO2, which is the nitrogen dioxide, plus oxygen gas. So the next thing that you need to do is you need to balance out this equation. So you have 4 oxygen at the product and you have 5 oxygen at the reactant. So the easiest way is to make this oxygen into a round number. So you times 2, so you have 10 oxygen altogether. And then since 2 times 2 is equivalent to 4, definitely you need to put 4 over here because you need 4 nitrogen. So 4 times 2 is equivalent to 8 plus another 2 is equivalent to 10. So it balances out the oxygen that you need. Okay, so the next step is we are going to write the rate expression, but we are just going to write the rate expression that we need. So you want to approximate the rate of nitrogen dioxide. So I'm just going to do the rate expression for these two only. Alright, so the rate expression is going to be half delta, because this one needs to be negative because it's on the reaction, delta concentration of N2O5 over delta T is equivalent to positive 1 over 4 delta concentration of NO2 over delta T. Alright, so in this question, it is given that the rate of N2O5 decomposition is equivalent to 4.2 times 10 to the power of negative 7. Therefore, the value here is equivalent to this. So I'm just going to plug in the value. So negative 1 over 2 times 4.2 times 10 to the power of negative 7 is equivalent to 1 over 4 delta concentration of NO2 over delta T. So we're going to settle this part first. So we can say that 1 over 4 delta concentration of NO2 over delta T is equivalent to 2.1 times 10 to the power of negative 7. So we are going to check again the question. It asks you to approximate the rate in which nitrogen dioxide. So this is 1 over 4 nitrogen dioxide. So we are going to bring this over here. So delta concentration of NO2 over delta T is equivalent to 4 times 2.1 times 10 to the power of negative 7. Hence, you will get 8.4 times 10 to the power of negative 7. So this is the final answer for the fifth question. Right now we have arrived at question number 6. Consider the hypothetical reaction below. A plus B will produce C and you were given the table. So determine the rate constant for the reaction. Alright, so in order for us to find what is the rate constant, so we need to do one by one in accordance to the rate law. So in general, the rate is equivalent to the rate constant, concentration of A to the power of X times concentration of B to the power of Y. So now we are going to find what is X and what is Y so that we know what is your rate constant. So we are going to start with finding what is Y. So in order for you to find what is Y, you need to find the value of the concentration of A that is identical. So in this case, these two, which is experiment 1 and experiment 2. So we are just going to plug in the value to find what is the value of Y. Okay, so what we have done now is experiment 2 divided by experiment 1. So this one you can slash out together with all of this. So 0.2 divided by 0.1 is 0.2. So you can write 0.2 to the power of Y is equivalent to 1. So you want the value of Y, so you need to bring it to the front. So Y ln 0.2, so you need to put ln over here as well. So your Y is equivalent to ln 1 divided by ln 0.2. Therefore, you will get your Y is equivalent to 0. Okay, now we are going to do the same drill to find what is the value of X. So the value of X, we need to find the concentration of B that is identical. So we are going to use the experiment 3 and also experiment 1. So we're just going to copy this again just as what we have done just now. Right, so just like the one that we have done before, the one that is identical, we can slash out. And here 16 and 4, so this one is 1, see this one is 4, therefore 0.2 divided by 0.1 is equivalent to 2, therefore we can write it 2 to the power of X is equivalent to 4. So we want to find what is the value of X, so we write X ln 2 is equivalent to ln 4, hence your X is equivalent to ln 4 divided by ln 2, so you will get your X is equivalent to 2. Right, so just as the beginning of the discussion, we know that rate is equivalent to the rate constant times concentration of A to the power of X and concentration of B to the power of Y. Therefore, for this case, A to the power of 2 and B to the power of 0. So now you were asked to calculate what is the rate constant. So what you can do is you can plug in any of the value here to find what is the value of your K. So you can use any, so I'm just going to use experiment number 3. So the rate is 16.0 times 10 to the power of negative 5 is equivalent to K, concentration of A, which is 0.2 to the power of 2. I'm not going to put B because to the power of 0, so it's going to be 1 anyway. Hence, your K should be equivalent to 16.0 times 10 to the power of negative 5 divided by 0.2 to the power of 2. Therefore, you will get the rate constant is equivalent to 4.0 times 10 to the power of negative 3. So this is the final answer for the 6th question. Alright everyone, this is the end of this week's video. Thank you very much for watching this video from the beginning till the end. I hope that this video will help you to understand more on how to answer all the questions from test 2. So I'll see you again next semester. Take care and be good. Goodbye.